2019 Exam 1, Question 4. All right, classic wordy question with the extra twist of it being a not. You've got the words isomorphic, you've got connected graphs, you've got faces, you've got complete graphs. So there's things you probably need to know there that'll make you more resilient when you're posed with a question in the exam. So let's have a look at each statement and just determine why they're true or not true. And this is always good because they might ask a similar question but in reverse. Okay. Now graph 1 and graph 2 are isomorphic. Isomorphic means they're the same. And you can tell they're isomorphic straight away because you've got 1, 2, 3, 4, and then 1, 2, 3, 4, 5. Can't be isomorphic if you've got different number of vertices or different number of edges or different kinds of connections. So isomorphic basically means same graph, different orientation. So actually the one that's not true is A. But we're good studiers, let's go through those other ones. Now, graph 1 has 5 edges and graph 2 has 6 edges. Look, 1, 2, 3, 4, 5. Yes, 1, 2, 3, 4, 5, 6. So that is true, which is why it's not the correct answer. Let's have a look at some of these other ones. Both graphs are connected graphs. So a connected graph means everything's joined up. So if you have a vertex out here, graph 1 would not be a connected graph, or it could be a graph 2 is not connected graph, depending where that vertex does not belong. So they are both connected graphs because you don't have any isolated vertex. That would be an isolated vertex. So there's another word for you, isolated. 3 faces. So 1, 2, not forgetting the outside is 3. 1, 2, outside is 3. So that is true. And then it says, so neither, using that, neither are complete graphs. For this last one, a complete graph is every point connected over the point. So if I was just to do that, so in a complete graph, you're missing this line. And then this one, you're missing quite a few, because this is basically the classic pentagram. So you're missing that one, and that one, and that one, I believe. Now, formula for complete graphs. Vertices times vertices minus 1 over 2. All right, so if you look at this, you've got 4 vertices here, so that would be 4 times 4 minus 1 over 2. Well, that's 4 times 3 is 12, 12 divided by 2 is 6. You do actually have 6 if it was complete. That would equal 6 for that one. And with your classic, now that graph 1 can also be made planar. So there's another word to make sure you understand, planar. Because if you took that line and just stuck it on the outside like that, it would be planar. If you look at graph 2, which is your classic pentagram, for all of those who are into your I think I need another line there, don't I? There we go. You should have, well, that's 5 times 5 minus 1 over 2. So that's 5 times 4 is 20, 20 divided by 2 is 10. So that would equal 10. And if you do count those, you should find that there actually are 10 lines. So it's good to perhaps know that formula for complete graphs, how many edges you need. Do you know what a planar graph is, what an isolated vertex is, what a face is, what connected means, what isomorphic means? All should be in your study notes with examples.